construction, human segmentation models, some really relevant and some really specialized content if that's where you are and that's the field you're in. So I just wanted to touch on quickly. I mentioned there that I've already recorded podcasts with Rafael and Elias so far this year. So if you haven't checked it out, make sure you have a look at the Computer Vision in Production podcast. We're streaming on Buzzsprout. What Buzzsprout does cast the podcast onto Spotify, Stitcher, Google Podcasts, and all the leading channels. So we've released 14 podcasts so far this year. And over the last 4 weeks, we've released 3 episodes with Florian Lech, who is recently after joining a new business. But at the time we spoke about the products he was working on at 20 billion neurons. Apu Shaji, who's a founder at Mobius Labs, talk about, some of the trends he's seen in deep learning and computer vision over the last number of years, maybe 8 years since deep learning was introduced. Then, of course, you'll find out a lot more about Volograms today. But the first Irish company to have on the podcast, so up the Irish, we had Kostas and Rafael, who was released today. Now, for anyone who is interested in other events that are also, I suppose, sitting very closely to computer vision in production, you may have seen me speaking at, some sort of social events. My company are also responsible for hosting the events, Women in DevOps. So in this case, we're going to have a live webinar and panel discussion about building purpose-driven technology. It's going to be, I suppose, all about building purpose-driven technology around its use case and how you're involving stakeholders in it from the start. And then also with most of these women in DevOps challenges or panel discussions, they talk about, how they can build them with purpose to meet diversity. And ethnic diversity as well, and not only just gender diversity. And then just lastly, before I allow Elias to start, we have 2 events, computer vision production events, that will take place next month. So on June 16th, we will have our very first panel discussion of the year. We're going to have 4 leaders from the industry, and it's going to be talking about hiring world-class talents, as opposed to, building world-class talented teams, as opposed to just hiring world-class talents. This topics that we're aiming to cover is, it's very expensive to try and go out and find a unicorn on the market. They also don't exist. And when they do exist, they're being paid crazy money, versus how do you motivate and train a team to create a rock star talented team of engineers in-house. And then the second event that's going to be happening next month will be on June 23rd. If Junli, Karen, or Isabel are listening to this, I do apologize. That is a provisional date that I've booked, but the event will definitely take place on June 21st. I just wanted to have some sort of slide or something to show for the event. But I suppose, look, without me taking up any more time, I can pass it over to Elias, who's got a very showcase, I suppose, presentation that he's going to give you. Elias, do you want to jump on, introduce yourself, and start us off?
Yes. Do you hear me all right?
Absolutely incredible. Yes.
Okay. Do you see me?
Yes.
Okay, so hi, I'm Elias Vansteenkiste. I'm the artificial intelligence architect at Segmentive. And today I'm going to tell you something about the real-time video segmentation that we do here at Segmentive. And we mainly focus on mobile devices. So I'm doing this presentation in our virtual studio. So if you're also interested in this, you can take a look around. Okay, let's start. And why human segmentation? So why are we focusing ourselves so much on human segmentation? It's actually a key technology in several applications for more than half of a century. We maybe named it differently, but it is a key technology. And the first time it came around was in cinema. So the first green screen technology, at that time they used blue backgrounds, was being developed in the 30s, and in the 40s, The Thief of Baghdad, which was the first movie to really use it. And actually it won an Academy Award for visual effects. But they still used blue backgrounds. And then, of course, in the newsrooms, everyone knows that these green screens are used for example, to present the weather, but also to show some backdrops and everything. But then fast forward in the last decade, people have been trying to get rid of these green screens. And this is useful for a lot of applications. So one of them here is, of course, Apple's portrait mode, introduced by in the iPhone 7, I think, where you want to try to create kind of like a depth effect, a blurring depth effect. You want to fake a big lens with a normal iPhone camera lens. So they actually want to cut out the human and blur the background. So this is one technology. Then another one from Apple is ARKit, where you want to actually do a kind of mixed reality, and you want to put yourself inside an environment which is in between a virtual environment and the real world. And so if you want to put yourself in between objects, the computer needs to know, hey, this is the human, and I need to put it in front of the bowling ball and behind the pins or something like this. Okay. So then, of course, the pandemic hit, and everyone knows this guy. So it came very apparent that virtual backgrounds are a necessity. So you want a blurry background, and then, of course, all the major programs try to make Segmentive real time and not blowing up your computer while you're doing that. And then we also are now looking at these kind of applications where VR streamers want to actually superimpose themselves on the virtual reality to be able to share their prowess and their talents. As you can see here, this is a Beat Saber where you need to slice virtual cubes on the tone and the beats of music. So yeah, and people like to share these kind of movies and play around. So we actually are trying to make this happen. We have a client which is called Live, and they are actually using our technology to make this happen without a green screen box of several thousands of euros. As you can see on the left side, you see this kind of thing. So we want to try to make it happen. I think we have some small video here of me playing inside VR, playing super hot. But we want to actually do this even more accessible. We want to do this with a mobile. We can just use your iPhone, and you can just have Oculus Rift. Okay, but this is where we are, but where we want to head is even a bit further out. So these human segmentation only supports a single view of the VR, of the virtual environment. But in the future, we want to go to a multi-view where we can actually change the perspective. And for that, segmentation is not enough. So that's something we're also actively looking at. And as an example, if you want to make expensive camera movements, you need to buy these kind of moving robots, or you need to have somebody that does it for you. And this baby costs $250K. And it costs you $4K dollars per day to rent. So this is our end goal if we can make this happen. Okay, and so next up, I'm going to talk a bit about how we measure segmentation quality and how we kind of try to match that with human perception to achieve what we already have achieved so far. So video segmentation typically is done in 3 steps. You have detection, you have segmentation, which is the rough outline, and then you have mapping. So what people with hair or some fine details that are merged half of the background, how do you get them out? And this is annoying because every one of those steps has metrics and you need to measure it, but we actually need to do that all at one time, and we need to find a way to kind of get this done. So we try to combine these metrics, and so we have already before we actually looked mainly at mapping before, but we actually tried to merge with video segmentation. And when we did that, we actually found out that if you take a look at motion estimation, that this is very important to to get a metric which is closely correlated to human perception. So this is a graph from a paper from 2015, perceptually motivated benchmark for video matching. And they proposed some new metrics, and there we saw that they actually improved the correlation with humans' perception. And one other thing they found out is that if you take a look at the speed of the human inside the scene, then we actually see that if a human is moving slow like this, then segmentation errors are actually way more important than if you move very fast. Then this actually is not so important anymore. Okay, but the problem is all these advanced metrics are actually not really accepted in the academia. For example, very new matching techniques like FBA matching, they used the advanced image-based metrics, but none of the video-based metrics, and even really works that focus on video-based metrics, they don't use it that often. So I think that's a problem, certainly for us, because we want to, of course, have a good segmentation. We don't care about who did it. Okay, so what do we want from a quality score? And so we want a high correlation with human perception. We want that it's easy to be measured. So something, a number between 0 and 100 or 0 and 1, something to understand 0 is the worst, 1 is the best. And also we don't want that every value that we produce is always in one small scale. So that's what we want from a good metric. And so we know that motion is important, but do we know why? So it's actually the human is very good at offsetting motion. And so that's why we actually need to take a look. How can we take that into account? What happens actually if it changes over time? And we also notice that edges are very important. So as an example here, you have the lady with the hair, and you can see edges, the hair. Some of it is background, some of it is foreground. This is very hard to segment. But if something goes wrong there, you will see it. It will see you. Also, fingers mainly are very important, because if a finger is off or gone, it's a problem. So yeah, I already told you that offsetting motion is very important, because we have a good in-house optical stabilization system and tracking. And so we are very perceptive of changes there. And so if we take a look at these hands and we divide it in pixels and we follow the fingertip and we actually take back the motion, then the changes in transparency there is actually the thing that you need to track the segmentation quality. And so we started working, so that was kind of the state where we were in academia. Now we're pushing it forward with Segmentive. And the first thing we figured out actually is, in our case, a mistaken classic matching metric, where people used the absolute value, absolute difference in the gradient, instead of using just the normal difference. And this helped us forward already a little bit. It already helped to improve the performance a little bit. It's stupid, but it's small, but it happened. The next one that we did is we took a look at more recent optical flow estimations, so motion estimation methods. And we saw that typically people used a very old one, this 2003 one. We just replaced it with something new from Microsoft, Mask FlowNet. And we saw that our correlation score went up as well. Then the next thing we do is if we take a look at the amount of change in our picture, and we scale it frame by frame by the amount of change, we can actually see a better correlation. So if there's a lot of change or there's little change in a frame, it makes our human perception kind of not overloaded if there's a lot of change, but you will notice less that something is off in some area. And this gives us another small boost in correlation. Then not only the amount of change is important, but also the upper bound of the error. So what does that mean is that if you have a certain, this guy jumping here, our colleague Nour, if he's jumping there, you have the edge around him. So if you do everything wrong and you don't produce any edge during segmentation, just a completely black or white, this has a certain value, a certain error. And if you scale your metric per frame by that amount, then you can get even a better performance, a better correlation. Yeah, this gave us some extra performance boost. And then another important one is if objects are moving very fast, we are less sensitive to this stuff. So what we did is just we scaled by the motion magnitude vector, and this kind of helped as well to improve our tracking of the human perception in terms of segmentation quality. Yeah, and so we are at this point now in time, and we are looking at other things now to even further track the correlation. And we are mainly taking a look at hands. They sometimes convey a lot of message, body language, and sometimes not. If they're moving fast, for example, then it's not so important. Face is very important. And so we already have something where we weigh the face a bit more and hands, but we're still trying to figure out what is the best way to correlate with human perception. So, and this was our chapter about segmentation. And the second thing I want to talk about is how do we solve our data problem? And this one is a bit also interesting, I think, for a lot of people. So the problem here is that if you want to have good ground truth for segmentation matting, it's very hard because you need to actually predict for every pixel how much foreground, how much background it has. And inside the arm, for example, it's quite easy. Outside the arm is quite easy, but on the edge, it's very difficult. Like you need to say, a human needs to say, okay, for this big pixel, we have 50% background, 50% foreground, maybe 40, 60. It's very hard to define. And so that's why we have another technique that we use. And we actually use just simulation and physically based rendering, just some rendering scenarios. So we have some architecture visualizations and we put some models in there. And so what we can do is we can place the models, we can change the perspective, we can change the lighting, we render that, and we can actually get some cool things like shadows and everything that are very hard to collect segmentation examples from. And so we can improve our model that way. So like for this example is just this guy in the same scene walking, and you can see because of the plant going into the human segmentation, you can actually get a very fine segmentation out that you can then use to train your model with. Okay, so that is the last technical thing I want to talk about. Now I want to shortly go over our SDK if you're interested. So we have an SDK. It's contains a segmentation algorithm, and we support Android, Windows, Apple, iOS, even Mac OS. We have a native C++ version and a Unity version, where we can also support different frameworks if you're interested. But it contains a real-time segmentation, which doesn't actually overload your GPU, and you can do so under rendering tasks. This is a screenshot of me using our test app. And you can see it runs at 60 frames per second, and it doesn't really overload the GPU, so you can actually see that. It will normally also see it works in different lightnings, different rotations and positions. It's totally not sensitive to stuff, and that's what we try to do. And so people can actually use this to create their own collaborative tools, their own Zoom kind of applications, or these scenarios in VR, for example. Yeah, and So in the future, we want to also have support for WebGL and Unreal Engine. We also are taking currently a look at relighting, accessor segmentation, which is a very interesting topic. So what do you do with this guy? Do you include it inside the foreground? Do we include it in the background? Then we also have relighting. If you're in a very dark environment or you're gaming, but your gaming is a very bright gaming environment, how do you kind of do that? So these are things we are currently looking at. If you have any kind of application and you don't know how to do it, we will gladly drop us an email and we will gladly have a talk with you. And if you just want to test out our demo segmentation app, just drop me an email and we can send you a test flight link. Okay, and then let's go to the next one. Is that it? Oh, okay, that's it. So that's it. If you have any questions, please go ahead.
Yeah, fantastic, Elias. Thank you. From me, absolutely well done. So if anyone has any questions, I probably should have set this up at the start. Feel free to pass them through in the Q&A box throughout. We'll look to answer 2 to 3 questions after each talk and then come back to any outstanding questions at the end. So right now, Elias, we have a question from Fabian. He asked, the transfer from synthetic data to the real world is usually a problem for computer vision models. What is your experience there? And do you only use synthetic data?
The trick is to not only use synthetic data. It is actually like if you use old, I remember in the first days that I tried this out, it was still a different project. And the data looked very different from your typical use case scenario. But in our case, we use this real rendered, ray traced scenes. It almost looks so realistic. So it's so close. It's good enough. There is not so much domain shift. And the model really learns those cases like shadows are important. What does it need to do if I have an object in the hand? Yeah, that is for the model much more useful than the small domain shift it needs to make. But it can be very different for your application. It depends on how your application is. You always need to take a look and solve those issues with the extra data or try to make it more realistic. But in our case, I think it works out.
Anthony, I have a couple of questions. Can I ask?
Yeah, jump in. I would have guessed you would.
Yeah, we of course we also have our own segmentation algorithm, and I know that it's a huge pain. And for instance, in our case, the quality of the reconstruction depends a lot on the segmentation. So when I was seeing your fingers, they look so great. So my first question would be, do these also work the same as good as they are working right now if you do the capture on the phone, for instance, in your demo app?
So in a demo app, it's a fast model, which so you can choose, right? So if you want real time with some extra rendering on top, we have a fast model for you, which you can actually, we can go back. It actually, this is the performance. Let me see. I didn't show my hands, but it has some small artifacts, as you can see around my head. But it's actually very good, I think. It does the job if you don't care about perfect segmentation. But of course, if you say we have some seconds to render, we don't need to show it in real time. That changes the story. Then you can do very good segmentation. With very little artifacts.
Yeah, because my experience, you always, well, when you're using like some deep learning method, at some point you have to downscale the image. So getting all those details is actually really tricky. So congrats, I think it's pretty good. I'm also surprised about the clicker that you're using, because one of the funny things that happens in our systems is that, I don't know, people do scan themselves with a cat or with holding a book or a mug or something like that, and that is never included in the model. So you were saying, well, you have to decide if you want to mask the clicker or not. So how do you do that? I mean, have you I don't know, identified a set of objects that you want to include and you include those, or do you have a more generic model for that?
No, so that's the case. So it's a data job. So what we do is we take a look at all the objects around people, if they are connected, if they're not too big. And then we train two models. So we train two masks. So one is the things around it and only the human. The other one is only the human. Some applications don't want the things you're holding inside. Some applications do want it. So that's why we provide the two, actually. Yeah, that's the idea. Because yeah, some people want the stuff inside. If you have, for example, go back. Yeah, if you have the VR scenario, for example, it would be weird if the glasses is completely like
removed. Yeah,
removed. Right? It would be really weird. So you want
or a mask. Somebody wearing a face mask today.
The coolest thing would be that they regenerate your face, but that's maybe a bit too far out. Yeah, so that's the issue there. So some people want it, some people don't want it. That's why we kind of are working on this different ways. If you want it in or not, you can choose. That's the idea.
Cool. Thanks.
Rafael. Cool. So question from Said Elias. He says on the delay in video compared to the sound, he's just asking, is it the latency of your computation?
Yeah, so no, not really. We are now actually in it's a studio. It's called SizeNet Sales Studio, Virtual Studio, a sales space, because it's actually used for sales. And we have this issue with Zoom. We don't have it with Teams. A lot of people use Teams to do this. But we actually know what the issue is. So we're now just sharing the screen, but we actually need to create a webcam, and then there will be less delay. The problem is that Zoom thinks we are sharing a desktop right now. And so it thinks it's not so bad if it's a bit, latency is not so bad for that. So that's why sometimes the video is lagging behind. So if we just then fake it and set up a virtual webcam, then Zoom will think, oh, it's a webcam, I can't make it the latency go up too much. So it's just an artifact of the setup with Zoom. Yeah.
And then last question we'll go to before jumping into the next presentation is from Manuel. I'm not surprised by his question being quite related to performance and hardware. He asked, how do you trade segmentation performance against inference speed in hardware agnostic applications?
So that's a mouthful. Can you repeat it again?
So it's, how do you trade the segmentation performance against the inference speed in hardware agnostic applications?
Yeah, so it's very easy. So we have a metric and we call it flops per frame. And so if we always produce as a separate metric. So we have a segmentation quality on one hand and the flops per frame. And so when you make very different architectures, you will see, or you use different bit widths, or you will see either a drop in these flops. And so there's always a trade-off, right? For every model is a trade-off, but typically if you have a better data set, for example, then this Pareto front where you can choose from will lie a bit further. So this is our job, to provide different points on this front for people to use. Some people have very, very strict computational issues on the edge, real time. For those, we make a model which is maybe not that good of a quality compared to a high quality studio setup where you can just run the model on the GPU. But in general, that's what we do. And we try to make big paradigm shifts. When doing new experiments, we always try to, computational power is something you can actually know before you start the experiment. Because you know how many layers you have, you know how many, how you will use the model with the video. So we calculate these computational requirements even before we start training. It is reported, and we try to do some things to make that better, right? So this is more like kind of an architecture software issue, or like can be tracked that way. Quality is something you can only assess after training, after you've done your test sets. But yeah, does that explain a bit how we work? So we have the one hand, quality, which is measured after training. On the other hand, we have speed, which we use flops per frame. And of course, depending on the input resolution. We also have a way to deal with high resolution and how to make that more scalable.
Fantastic. Elias, I really do appreciate it. That was a fantastic presentation. So if anyone does have any questions, I know we've had one come in, but just to try and make sure we're moving things along and to give everyone else enough time, we'll come back to any outstanding questions at the end. So look, if everyone was here, you know, round of applause. But thank you, Elias. I appreciate it. And Nour, if you're ready, if you want to jump on, introduce yourself and kick into your presentation.
Yes, sure. Let me share my screen first. All right, you see my screen?
Yeah, it's just about to load up. Yeah, perfect. Got it all there now.
Cool. So hi everyone, I'm Nour. I'm an applied scientist in Zalando, and today I'll be talking to you about AI in fashion size and fit. So I will start by introducing the problem, complexity, and the impact. We'll go through some of the challenges and the data that we use. I will summarize some of the algorithms that we have in production, and I will focus on one of them that is based on computer vision. But before that, let me tell you about Zalando, in case you don't know the company. We are a leader in Europe fashion e-commerce, and we have many customers and many brands and articles and thousands of them that are available on the shop. So we have a lot of data. And you might wonder, what is it about size and fit? Why you have a whole team called Size and Fit? Maybe this example can give you some hints. So probably you're familiar with such a situation where you buy something either online or in the store and you try it out and it doesn't fit you. So this situation is very frequent, and it's even more challenging if you're buying online without seeing the garments. And actually, half of the items that get purchased online are returned. And there are many reasons that they get returned, of course, but about 1/3 of the reasons is coming from size and fit. Having this learned now that there's a lot of complexity in this, and there's a huge impact of these many returns, you can imagine that if we fix this problem, we will have much better customer experience and much better for the benefits for the business and also for the environment. But before we get to the solutions and the impact of this problem, let's take a step back and see why this problem is so complicated. So there are many reasons behind it. We'll start with a bit of history. So before mass production started, people used to make their garments at their family tailor, or maybe some member in the family would know how to make garments. But when mass production started, all the factories suddenly became far away from end customers, and they started to use some statistics of the human bodies that are outdated or maybe based on non-representative samples. So we started to get more sizes that are not very well suitable for all the people. And then there's also the conventions for behind sizes. So all the labels that you read, they differ between countries and brands and the type of the garment. So you see sometimes the letters like small, medium, and large, or you see some numbers, and it differs from country to country. And there's also the concept of vanity sizing. So what it means is that some brands, they deliberately change the sizes of the labels that you see on the garment because they are targeting some specific customer category. to add to the complexity, the garments are multidimensional. So you can see that for jeans, for example, or any trousers, you have the waist and you have the length. You have many dimensions in the size of the garment. So it's adds to the complexity to the size. So our team mission is to ensure that the customers get the right size and fit from the first time. This is what we want to achieve eventually. Disciplinary team, we have different skill sets on the team, and we have a dedicated applied science sub team. I'm just gonna focus today on this part. Let's talk a bit about the challenges that we face from the applied science. So from the article side, so when we talk about the articles, the garments themselves, we face multiple challenges that can make our data science work more difficult. So the first thing is that the different sizing systems I mentioned before, they differ between categories and brands and countries. And when you want to use this data in any model, you want to have them all unified to one system or have some mapping that you can transfer in between them. Also, we have the new articles that have still no sales or returns, so we don't know much about their sizing behavior. We also have the ambiguity and the low quality of the fit data. So what brands provide describing the fit of a garment can be non-descriptive enough, or it can have some redundant information. So there is no uniform way that brands also describe the fit of the garments. So some brands might call skinny jeans skinny, and others they would call it small or tight. So you also face this kind of ambiguity in the data itself. There's also the delay in the feedback that we get. So the return process, all the customers, of course, can return what they purchased, but this process is not very fast. So it can take some days to weeks due to, of course, the logistics process itself, but also because it depends on the customer when they decide to send it back. And from the customer side, there are also a few challenges. So from one account, sometimes it's the whole family that is buying from this account. So it's difficult to figure out which size is for who. So between one account, there is maybe 2 or 3 people that are using the same. Also, there are new customers like the new articles, and they have still no purchases or no returns. So it's very difficult to tell anything about their body and what the sizes would fit them. And yeah, since we're talking today about how human and AI work together, it's also important to mention that human behavior is sometimes very tricky, especially, for example, with respect to data sharing. So, and their willingness to listen to the size advice. So when we provide size advice, it's not always that people are convinced that we know a lot about them to give the advice in the first place. And the topic is very sensitive. It's about their bodies, it's about their sizes. So the customer behavior is very different from one customer to another. And on top of that, there's a huge expectation from our advice that is explainable, that is accurate, of course. So we need to provide some reasoning behind our advice. When we say we think that you should buy something small or large, we should say why this is the case. So talking a lot about the challenges, let's talk about the data now. This is the key to any data science product. So I will start with the article data, what we use from the garments and the shoes perspective. So first thing is the purchase and the return data. I already mentioned that this is a very important resource for us, especially in the size and fit team. because customers can give us the reason why they returned the articles. So when they purchase something, they can say, I'm returning this because it's too big or too small or something. Of course, challenge is here that purchase per category, they can be very sparse. So the data is not sometimes not very rich in one category. And on the return side, I mentioned before that it can be delayed, but also it can be very subjective and noisy. So some people don't provide the reason. Of course, it's not mandatory to do so. So you don't have the complete picture about the customer and what they prefer. And it can also be very subjective. Even when they provide the reason, it can be, it's depending on how they perceive the size and fit. Of course, we use article images. So today, this is a computer vision community. So yes, we also use visual data. We have the different types of images, and there are also videos, but for size and fit, for now, for production, we use images. We have the pack shot, like when you see the article on white background, and also other images with the human model, fashion model wearing the item. We have an in-house station that collects expert feedback for size and fit, because this problem, as I mentioned before, is very challenging. Expert knowledge is very, very critical and crucial for our work. And we have fashion models and experts in the domain of size and fit that fit the garments and provide us with detailed feedback. We also have established some standards around the fit and the shape of the garments. So how we describe the articles, we use unified language inside the team. And from the customer side now, we have, of course, the place for customers to get their feedback. So I mentioned before that they can return. And then they can indicate the return reason online or offline. Especially in Germany, people like to return with the return slips. They indicate the reason on the paper, but also they have a place on the account to provide us some more information: what fit well, what was shopped for other people in the household, to give the space for them to communicate with us and tell them which data we are using in the first place to give them this advice. So this increases our customer trust in the algorithms. There's also a small box that we show for new customers that just come to Zalando for the first time. And we ask them to give us some item that fits them like their favorite fit. We ask for the brand and the size of this item to just have a initial imagination what their size might be. So for more engaged customers, we have a sub-service called Zalon. Zalon is like a subscription that people provide more information about themselves, their fashion preferences, and they receive from designers a box of fashion items that they can keep or return, of course. And what we use from our team is the data that they provide us, the detailed data about their body and their fit preferences. So they provide weight, height, and age, some more detailed information about the top size, for example, the trousers size, and some measurements of the body. This is also some source of data that we use. Of course, it's more limited here because we're talking only about the very engaged customers that are subscribed for this service, but we also make use of this data. We have also this body measurement from 2D images. So this is yet to come. It's of course being done for several iterations now, but it's not all in production yet. But we have this based on computer vision algorithms. We take 2D images and get the main key points of the body and predict the body measurements for the customer. So let's talk about the algorithms in production. So we have two major types of advice that we provide for the customers. One is more article-centric size advice. And for this, we have two main algorithms. The first one we call size flags. I'm just going to give you a high-level overview. It's just a piece of advice that we show when you go to the article page, and we tell you that this garment, this dress, for example, might be smaller than the usual, so we recommend you to go one size up. So it's all about the garment itself. It's not about what we know about the customer. It's just us telling the customers that from our knowledge of this garment and the other garments, we give you this advice. And this, the size flag that you see here is based on the purchase and the return data. It's basically a statistical model. It has some more complications. I'm going to go through some details later. But the main challenge here I mentioned before is that the purchase and the return data are limited. Which means that we have cold start problems. So for new articles or for articles that have delayed returns, or they just are active for a very short time. So when you have a trendy item, then you end up with a situation that you can't say much about the item. And here we use computer vision. So the contributions for this algorithm we call SizeNet, that it leverages this visual cues that we see in the images to try to infer the size characteristics of the items. And it's very effective to tackle the cold start problem. So when we don't know much about the item yet, we can already say something from the image. And it's based basically on the weak annotations that we get from the customers. So how the approach look like? We have teacher and student approach that is based on a statistical model, that is the teacher, and the student is based on images. So it's a convolution neural network. The teacher, as I mentioned, is statistical model. It's basically a binomial likelihood that we take the sales and returns of the item and compare it to the category. And we see if it's behaving very oddly in comparing to the others in its category and in the same time frame, so in the same sales time frame. And based on that, we can say, okay, this article is really behaving off. So we say this is a problematic one and has some size issues. From there, we get also some confidence level. So the statistical model provide a prediction, a label for the item, but also some confidence level, how confident it is. And the student part, it's trained based on what the teacher has labeled from the return and purchase data. But these are only labels for the student. The student has no access to the sales and returns and only sees the article images. It's basically have a backbone feature extractor. It's based on Fashion DNA. It's another project inside Zalando. It learns article embeddings that are very specific to fashion items. And on top of that, we have a multi-layer perceptron that learns from these embeddings the size issue. And we use the confidence score that came from the teacher before to control how confident article contributes more to the learning of the student. And here I'm showing you a bit of evaluation that we published 2 years ago. So we compared the SizeNet to 2 other methods. One is based on attributes, so the article attributes. Instead of using images, we use K-hot encodings of binary fashion attributes that are manually enriched. And the other one is very similar to the architecture of SizeNet. It's just replace the article features. Instead of using the embeddings coming from the fashion DNA, we use ResNet pre-trained on ImageNet. And what you see here is that, so the 3 baselines, they perform good, but the best one is the attributes, which is based on the manually enriched attributes. SizeNet outperforms the ResNet baseline and has somehow a similar performance to the attributes one. And it doesn't require any manual annotation. So images are available anyway when we have any article online. So it doesn't require any extra cost. And here I'm showing some of the explanations of the network predictions. So this is based on a method for network explanation called RISE. We have generated random masks on the images, and we try to see which part of the garment is triggering the prediction. Where the prediction is coming from, so where the size issue is coming from. And what we can see in this qualitative analysis is that for the true positives, so where the network was correct about the prediction, we have more localized heat maps in comparison to the top false positives, for example. And also we can see some limitation of this approach. We see that, for example, when we have some special design of the garments, it can be misinterpreted to be a size issue. So how we use this in production, you may be wondering now. We have, I mentioned before, the fitting station. These are the experts that provide feedback. But this is limited in capacity because they can only fit hundreds or thousands of articles. They have a limit, of course, but the SizeNet model has no limit. We can pass in how many articles we want. So basically the assortment is split into 2 algorithms. One is the SizeNet that takes the images and gives some prediction. And the other one is the fitting station that gives us some feedback, expert feedback. And then based on those 2 pieces of information, we have some prior on the article behavior already, and we give a size flag of the article and show it to the customer. I'm gonna tell you about the other type of advice that we provide. It's not focused on computer vision, but I think it's interesting to many people attending. So the other type is customer-centric. So here, instead of saying that we know this about the article and we should buy this, we give the customer what exact size we think they should buy. So for this pair of trousers, for example, we say that we think you should buy 30 by 32. And here we have multiple algorithms behind this piece of advice. So one is the baseline recommender that is active in all countries. It's basically based on a statistical model that learns the size distribution of the customer from their purchases and try to predict what they should buy next. And we also have a deep learning recommender that are being tested in many countries now. And they use, besides the size of the item, also some other features of the article to give the recommended size. And I mentioned before the cold start customers that they are new to the platform. They have still no purchases. For those, we use customer in the loop. So, for example, for the Zalando customers, where we know more information about them, they give us some detailed data about their body. Here we use gradient boosted trees that take the questionnaire attributes and the brand of the article, and we train it using the customers that have both Zalando account and purchases on the platform. And at this time, we can recommend items to all the others that have only the attributes. And here, what you see, what you see here in the plot, that it takes around 15 to 20 purchases to for the baseline recommender to catch up with the cold start recommender. Also on the customer in the loop, so having the human in the loop of the training, we use this box I mentioned before, where we ask new customers about their favorite fitting item. Here we take the article brand and the size and use it as an initial purchase for the customer to start giving them some recommendation. And we also mix the purchase data with the customer data. So we have a meta-learning approach that consider the customer as a task and try to learn from these different tasks how to map the customer to their sizes. And yeah, it basically learns this linear relationship between the customer embedding and the purchases of the customer. And here you can, of course, ingest different types of data. It's not only the purchases. I mentioned before that we use other article features. And it can improve the Zalando customer recommendation by including the customer attributes in the embedding itself. So instead of representing the customer by only the purchases, we also add the attributes. And we can see a noticeable improvement in the accuracy when we do that. I think that's it. Yeah, that's it for me today. I'm happy to take questions.
Nour, I really do appreciate it. It's funny, my girlfriend made her first order on Zalando last Friday, and it's now her new favorite platform.
Cool, great.
You wouldn't believe. I know you have an office in Dublin, but you wouldn't be. It wouldn't be the most well-known platform over here. I think it's great. Not to go off topic, but first question coming in from Ed Zimmerman. Hey Ed, how you doing? He asked, how does the model deal with rise? So hips, natural waist are typical insufficient data points.
You mean the noisy data? Is this a question? Did I get it right?
Yeah, so I suppose the question is just in the chat box there as opposed to the Q&A. It's like, how does the model deal with rise, ? And it's like hips, natural waist are typical insufficient data points.
I don't know, I don't see this question. Yeah, well, I mean, that's the thing, like, because we have, for example, when I mentioned the SizeNet model, because we use the confidence score to weight the loss function, we control when there is something noisy, and having this statistical models in place where we can provide some confidence in the prediction, it's not only probability, you can control what you want to learn from there.
Perfect. Cool. Sorry, I think I fizzled out there just a little bit as well. Still on. Can you hear us, Nour?
I can hear you.
Oh, sorry, perfect. I thought I was frozen. Perfect.
My connection is not the best, so it might be.
Next question is from Niels Heyman. When I seen him on the guest list, I kind of expected him to drum up a question for you. So look, thank you for your talk. He has a question. Does Zalando work with images from vendors, 2D or 3D, or do you make your own image data sets from all your products?
Yeah, it's a mixture actually. So we have both. We have partner brands that upload their images on their own. They have guidelines, of course, that they need to follow. But yeah, I mean, if you look deeper, you can see sometimes some differences. And also we have the items sold by Zalando where we make our own images, and yeah, these are controlled in-house, of course.
Yes. And then we have a question from Lalit. It's, do you use CAM for determining discriminative parts?
I didn't get the question, to be honest. What is CAM?
Yeah, it's CAM. I'm not sure myself. Maybe Lalit, if you can give us just a little bit more on CAM. I actually, oh sorry, class activation MPs.
Yeah, no, actually. So yeah, that's a good question.
Maps, sorry, class activation maps.
Yeah, so the example I showed you before from the heat maps, it's coming from the network. So it's really about what parts of the image were used for the production. But it's not class specific.
Okay, cool. I have a question myself. So I know Zalando have acquired Meeple, the Swiss size and fit startup company. I suppose in terms of their integration to Zalando, and I suppose knowing what they do, are you going to be going down the line of having like a virtual fitting room and try on room that you can take a picture from your phone and try on?
Yes. So before that, in my team, we have a sub-team working on this problem. And now that we acquired Meeple, we have them as part of Size and Fit. And this is work in progress now, going into this direction. I think personally, as a shopper, this is the future for online shopping, because when you don't see the item on yourself or something that looks similar to you, it's very hard to relate. And yeah, I mean, with the current situation, it's also very realistic to go into this direction.
Yeah, and it's definitely responsible for a bunch load of returns also, right?
Yeah, of course.
Nice. I guess you probably see a lot of similarities with the topics Elias is talking about and what Rafael will be talking about in terms of how you're going to look to build that virtual fitting room, right?
Yeah.
Cool. Well, look, I think just to again keep it moving. I know I've kept people running along, but Manuel, I know you have a question there for Nour, so we'll come back to that. If anyone else has a question, keep them coming in the Q&A. We'll come back and answer all the questions after Rafa is finished. But yeah, Nour, thank you. And then to drum up, Rafael, if you wanna get started and give an introduction and jump into your presentation.
Of course, I was muted.
Yes, I was going to say, I think you're muted, yeah.
Of course, I mean, it had to be me. So, hi, everybody. Can you see my screen?
Yeah,
Perfect.
we can see everything. We're all good.
Great. So I'm Rafael from Volograms. Thanks so much for having me here, Anthony, and also for like the opportunity of chatting with you in the podcast there that has been released just today. And a very interesting conversation. Hopefully, I can show you a little bit of what we've been working on for the last few years. I'm not sure if it's going to be as technical as the previous two presentations, but I hope you enjoy it anyway. Cool. So as I was saying, my name is Rafa Pajes. Actually, my name is Rafael, as you can see already there, but Rafa sounds a little bit more young. Rafael sounds like my granddad, you know, not that I don't like my granddad, but I just don't want to sound so old. Anyway, Rafa Pajes, I'm the co-founder and CEO of Volograms. And my background is actually, even though I'm the CEO, it's in computer vision. So I did a PhD in computer vision, specifically in 3D reconstruction. And specifically 3D reconstruction of humans. So I have more than 10 years of experience in the volumetric capture industry, even though the industry itself is not that old. But you know, I've been working with 3D reconstruction technologies and methods for many years since I started my PhD. So Volograms is an Irish company. We're based in Dublin, even though I am right now in Madrid for the first time in the last 2 years since the pandemic started. But yeah, we're an Irish company based in Dublin. And what we do at Volograms is that we power the capture of 3D humans. So this is a big example of some of the models that we've been using or capturing throughout the last few years. We've been doing this professionally so the company is 3 years old. So we've been doing that for 3 years. And we've done this type of 3D models. They are dynamic 3D models. So you record a performance and we've used them in many different types of applications. Here are just a few of them, the ones that we can show, but they are in areas like art and performance, where you see kind of a dancer somewhere and a couple of them there, storytelling, training, corporate communications, marketing, culture, tourism, fashion, and many others, like for instance, sports, that we're right now working with a company that they're doing training for their athletes and understanding how the movements are and stuff like that. So this technology is called volumetric video, so volumetric capture. That's probably what you've heard in the past, and it's actually pretty complex field. So capturing these 3D humans, so getting into the volumetric capture field, it is actually very complicated. So you typically need these massive camera systems, as the ones that you see in the image, with hundreds of cameras. In some cases, you might use motion capture setups. You need for sure like specialist people to manage to operate these camera setups. You need artists sometimes to go and fix some of the issues that you get when you do the capture, and clean up the meshes and get them ready for being used in production. And the problem is that doing all this processing, all this reconstruction typically takes weeks. And the budgets in some cases go above the 20K per minute. So this is at the end of the day something that is only accessible to very high-end productions and people with very deep pockets. So at Volograms, we were actually trying to do the opposite. We were trying to identify what were the problems of this technology and try to make it as simple as possible. So we think that there's a very important opportunity here, and I'm not going to stop here about for too long, kind of explaining all these numbers. But as you know, this can be used in VFX, and it is being used in VFX in one way or another. And right now, there's like every year there's a huge increase in the amount of money that is invested in the the CGI shots. But also this is very important for immersive industries like virtual and augmented reality, because there's no simple way of bringing real humans into VR and AR. You typically have like avatars and stuff like that. And what we're trying to bring is real performances. So what we see is that the content is actually not matching the demand. So when we started working 3 years ago, we had this solution in mind. We call it Volograms Studio. So this is actually a solution that addresses the main problems that volumetric video has. The first one is that you need a lot of cameras. So we design a system that works with a lot fewer cameras than what you typically see in the industry. To give you a reference, the volumetric capture studio that we have in Dublin has 12 cameras, and Microsoft Mixed Reality Capture Studios, which is probably the kind of the highest end that you can see right now in this space, has 106. So it's already like 10 times fewer cameras than Microsoft. So that's the first thing. But we wanted to make it as adaptable as possible. So if you needed more cameras because you're capturing, I don't know, if you want more details, or you're capturing multiple people at the same time, you can throw more cameras and set up a bigger space and it will work. Or if you want to do a capture of a face or something like that, you can use fewer cameras, even less than 12, and it will still work. The second point was actually the processing time. So you need, at the end of the day, a lot of processing power to be able to do this, because you're basically doing a 3D reconstruction process at every frame of your, let's say, video. And then you have to put it into some kind of a temporal consistent algorithm or something like that at the end of the whole processing pipeline. Doesn't overflow your system with hundreds or thousands of 3D meshes, like with the OBJs and the JPEGs as textures. So what we did is we put all this reconstruction pipeline in the cloud. So you can now do your own capture with your own camera system. So you don't need to come to Dublin to do the capture, or you don't need to set up a studio following our guidelines, or we don't sell you the cameras. So even if you already have a camera setup that you're using for something else, could be photogrammetry, it could be other types of use cases, you can immediately transition to volumetric video just by using our technology, and you don't even need, the servers on that typically need, because you can do all the processing in the cloud, and you can go from several weeks of processing to just a few hours, which is significant. And of course, you can use it in many different use cases, as I was saying, depending on how you want to use it. You want to do it for high end, you want to do it for low end. It works for many use cases. So I wanted to show you here a few examples of captures that we have done in different types of studios in different places. This one here, the 12 camera setup studio with this guy here, this is the one in Dublin. So only 12 cameras, and you see the reconstruction is pretty good. We're even able to get fingers and stuff like that. There's a few here that are very interesting, like this blue guy over here. This was done with a temporary studio where you could just set up with a bunch of phones. So you probably can see the phones over here. They're set up in some kind of tripods. So what the company that did this, the capture, what they did is that they rented the cameras and rented the poles to put the iPhones there, rented the phones. They were not cameras, they were phones. So they just put them together with one cheap fabric. It doesn't have to be like standard chroma key or anything like that, and just with that data, we were able to get a full 3D reconstruction, full volumetric video. So I think the total cost of renting the 24 phones plus the tripods plus everything, I think it was like €500 or something like that. Well, typically, and they just used it for a day and then took it away, took it apart and returned all the phones. While typically you would have to spend like hundreds of thousands just to set up the studio plus everything else. But we work with other capture systems here. So for instance, this one is from the London College of Fashion. So they're using it for fashion applications. They had all these cameras to typically capture 3D models of the garments and stuff like that. And now they're transitioning to volumetric, so they can do virtual catwalks and some other new applications. And they didn't have to buy any new equipment or anything like that. But we have a few other interesting ones, like this one, very high-end face scan for visual effects. This one that we did for a theater play where we only need to capture the heads. So it's only 5 DSLRs. But we also, of course, work with super high-end setups like the one here. This is actually Samsung XR Studio in Dallas in the US that we've worked with them a couple of times, and they use our technology to do the 3D reconstruction. Even though their capture system is really good, the reconstruction, ours is better, so they use ours. And so yeah, this is an example of how you can actually use this technology with your own camera setup without us setting up a studio or charging you anything for it. But the most interesting things that we've been working on is actually to replace this camera setups just with a smartphone. So this photo here is from the Microsoft Mixed Reality Capture Studio. So you see how complex it is. Each of these totems has, I don't know how many cameras there. So what we wanted to achieve was to replace this massive thing with just a smartphone. As I was saying at the beginning, kind of the mission of the company was always to simplify this as much as possible, and going to the phone is kind of the simplest that you can go, because it's one single camera, everyone can do it, not even need for a specific phone. And the purpose of this is actually because we believe that user-generated content is very important for the future of any digital platform. So if you think, I don't know, of the internet, or if you think of the smartphone, they exploded when anyone could create their own content. So when you could easily create your own website or your own blog, it's suddenly when everybody just jumped in, and the same for the phone. Now with the phone, you can just take a photo, you can edit, or a video, edit it directly on the phone, publish it, distribute it. You can make money, and you don't even have to leave the phone. So when you can create your own content, this is actually when the platform becomes useful. But there's nothing like that for augmented reality. So all the content that you see right now in AR is created by a professional, by a technician, by an artist, but there's no content created by users. I'm sure that you guys have probably tried any AR application, and everything is like animals or 3D models or celebrities, but there's no you. There's no way for you to actually create some 3D model easily with your phone and actually put it directly in AR or share it or distribute it. So, and we think that's really important. So what we are working on is it's in this application that enables AR content creation for everyone. And I'm not talking about avatars like in this example here from Microsoft Mixed Reality, where you can create your own avatar or something like that. It's actually still a little bit far from what their vision is. This is actually the video that they put online about how the future of working together is going to be with this kind of holograms that you have, and photorealistic holograms with the AR glasses and stuff like that. But at the end of the day, this mesh platform is actually avatars, as you can see over here. So I'm not talking about avatars. I'm talking about photorealistic 3D humans that you capture with your phone. No need for any special equipment or anything like that. You can just do it yourself. And as you can see me over there, I'm not that small, and I don't typically stand on my table. So you can imagine that is actually a Vologram, as we call them. So this is Volue. This is actually the name of the app. It's right now in beta. We've been testing it with some users for now, but if you're interested, you can just go to getvolue.com and log in there, and we will invite you to the beta. And you can do the capture directly with your phone, the same way you would do a normal capture. You can then play with the resulting holograms in augmented reality. You can actually apply some of these filters that we have built for people to be more creative, and then you can play next to yourself, as you can see with this lady there, and share it. So this is Volue, the new app. This is actually done by a lot of machine learning, as you can imagine. So as I was saying earlier in my questions to Elias, to Elias at the beginning, is that we do foreground background segmentation with not restricted to any specific background. So we can do it outdoors, indoors, or anything. We do single view volumetric estimation. So no need for the camera setup. Of course, the reconstruction quality is not as detailed as you can get in a professional setup, but this is actually now very convenient because you have it on your phone. And we do so many other things like markerless 3D skeleton estimation. The messages are temporally coherent. We do also compression and coding. So part of the professional pipeline that we're using for our clients is integrated into this, let's say, consumer-based application that anyone can try. This is all powered by what we're calling the Forge, which is basically everything that we do in the background. The networks are slightly different from the consumer and for the studio clients. So this part here, it's slightly different, but at the end of the day, these are some of the things that we're doing, like from segmentation, as you can see over here, depth map estimation, volume estimation, and then merging all that information. We create different levels of detail depending on what is the application where the content is going to be deployed on. And this is a temporally coherent 3D meshes. So at the end, you don't have a sequence of meshes, but you have something that is small and coherent and you can use really easily. So when you do the capture in Volue, the app, it uploads the data to the platform, to Forge, which is in AWS, by the way. And then a few minutes later, you receive your models that you can just play with them directly in augmented reality. And this works similar to the professional client. So they can upload the data there, it gets processed, and at the end, you receive the results. So the vision of the company is that anyone can be an AR creator. Same way that right now anyone is a photographer or a videographer. We want anyone to just be able to capture their own content. So we think that's the 3D human capture needs to be simpler, and this could be potentially the start of a new wave of creative tools that work directly on your device. And just a few examples of how people are using it. Of course, some of them are just taking photos with themselves, being incredibly creative. These are all capture and then process and then download and use directly in the app. So you see some people are sharing them on TikTok or on social media, but we think that this could go a little bit farther. So this could potentially be integrated into any headset or anything like that, because it doesn't require for a specific hardware or anything like this. So that's it. I have a few examples I can maybe show you.
Yeah. Actually, before we jump in, do you want to show some of the examples? But that was absolutely fantastic.
Yeah, cool. I can show you, for instance, just very quickly. I have a few videos here. So this is one of the models that we have. This was captured in a studio with 60 cameras, and you can see how it looks. And I'm going to play it with different backgrounds. So how volumetric video ends up looking with how photorealistic it can be. So you can see there. So the good thing about volumetric capture versus, for instance, motion capture or versus, 3D scanning, with animation, this type of things, is that the movements are really captured from the video. So this means that some of the movements they wouldn't be able to replicate. For instance, if I raise my eyebrows, you see a lot of wrinkles in my forehead. If you wanted to do that with a traditional pipeline, what you would need to do is recreate all these wrinkles in my forehead via geometry, via polygons. By using volumetric video, you can do that with the texture very easily. So the performance at the end is incredibly realistic. So it looks like it's really there, even though it's just the 3D model. It looks more realistic than what an animated model would be. You can see this guy also in augmented reality captured with my phone. So you see that the models work well. This is actually, just recorded with the phone, and how realistic it is, like compared to the environment, stuff like that. Yeah. Somebody dancing behind. And I also wanted to show you, this is, for instance, this model of myself here is actually captured with a mobile phone. So you see that it's a 3D mesh, so it's not actually a 2D cutout that you can see, and you can see that it actually has like a full 3D shape. This is captured just with one single phone, and actually you saw the models beforehand. So it looks actually like a full 3D model. So you can do the same thing that you would do with a 3D model. I think here's the video of me doing the movement. That was the video that was used for the capture.
Very cool. Very cool.
Yeah, I have here, I think here an example of how, not this one, this one. So how does it work with the different superpowers that we call in? These are the kind of this 3D effects. So you see me over there again standing on my table, and how it looks when you start to apply all these 3D effects that we have over there. So these 3D effects are very easy to create. So we're talking with different creators that might be interested in building their own shaders, and then can be easily integrated also into the app. Cool. So yeah, that's it.
Really cool. Really cool. Thank you, Rafa. Look, we'll get in and we'll start asking some of the questions that we've had come in here. So the first one from Vidya is, how do you ensure the security of the human images you have? Where are they stored, and are they encrypted or destroyed post training the model?
Well, that's interesting. So so there's two things here. So we are for the I guess that you're talking for the app, the one that the consumers are actually doing the recording. So we don't use the data capture for the use by the user to train anything. So we only store them as long as the user wants to keep them. But we don't keep the original data. We only keep the results. So we're not interested in for now analyzing that. For training the algorithm, what we use is actually 3D models. So Elias was talking at the beginning about using 3D models to also for doing the foreground background segmentation. So we also use 3D models for doing the 3D estimation, let's say the volume estimation. And the good thing about that is that the models that we've used for training the algorithms were actually captured by ourselves. So they are our own 3D models that we have captured in the studio. for different projects and stuff like that. These models are only stored locally, so they're trained locally and not uploaded to the cloud or anything like that. So no need for having like an extra level of security, let's say, in terms of the platform. But yeah, it's an interesting question, because one of the problems that you have, of course, with this type of technologies is that you need a lot of data to train them. And we have been doing this professionally for a few years, which means that we end up having a lot of 3D models of actors and performers and stuff like that, because for every sequence that we record, we end up having a 3D model per frame of the video. So if you have 1 minute, it's like more than 1,000 3D models that you can use for training the network.
Excellent. Next question from Vikis, coming from India, which is fantastic. Didn't think we'd be stretching that far. He said, do you use statistical shape models of human body for 3D model estimation from single images?
No, I'm assuming that you're talking about SMPL or something like that. So no, these models work more or less well for some applications, but they don't generalize well with different type of clothing and stuff like that. So we're trying to be as generic as possible with let's say the type of 3D reconstructions that we can do. So we don't use SMPL or any other statistical model.
Excellent. Next question from Marvin. He says, the backend solution is working frame by frame or after recording the whole video? I guess that's a question. Is the backend solution working frame by frame or after recording the whole video?
Yeah, so I'm assuming that you're asking if this is like a real-time process. So
yeah, so that's it. It's underneath. It's like for real time or record, then upload, then process.
Yeah, right now it's offline. So you do record, upload, and then process. So this is for a few reasons. So there's one step of the process, which is estimating depth, that typically requires a few minutes, and or depending on how many cameras you have, if you're talking about the professional setup. And so some companies are able, or some let's say research labs are able to compensate with that by throwing there like a depth sensor or something like that. But a depth sensor gives you depth real time, but is very, very bad quality typically, and requires a completely different set of algorithms, and it's very problematic. So, and I always joke that if Microsoft, who has the Kinect, is probably the best depth sensor, doesn't use depth sensors in their own mixed reality capture studio. So it gives you an idea of how complicated it is to actually get real good results with depth sensors. So you can do it with depth sensors, but if you're using standard images, which also gives you the advantage of being able to do it outdoors, or because depth sensors typically don't work really well outdoors, you need to do it offline. Regarding the mobile solution, we have something that works more or less real time, but it's only for devices that have a depth sensor. But the system right now generalizes to almost any phone with a decent camera. So you don't even need the latest iPhone with LiDAR to be able to do the reconstructions with the app.
Nice. Just Rafael, can you just stop sharing the video, and I'll ask Nour and Elias just to turn their cameras back on, and we can go through the last questions that we have here. Just so you know, if ever anyone has any more questions, you can just keep them coming through. I suppose once everyone's happy we can kind of go until we run out. But Elias, are you there? We have Lalit, who's been waiting an hour nearly to get his question asked.
In the meantime, if you want, I can maybe answer Enrico. But I see his hand. So for now, the app it's only on iOS, but it's just because it's in beta. We are also developing the Android version, but the reconstruction pipeline is not dependent on iOS or Android. It just doesn't care. It just operates on video, let's say. But we do use the depth sensor if it's available. So that helps guiding the reconstruction. So if it's available, we use it, but it's not a requirement. So you will see that depending on the phone you use, you will get slightly different results.
Excellent.
Can you hear me, Anthony?
Elias, yes. So okay. Lalit had a question for you just at the end of your presentation. he asked, how do you handle multiple scales of objects during segmentation?
For us, most of the times we have two different use cases. So one is the typical portrait one, where you have in Zoom video, like you now, Anthony, looking, you have a portrait style, cut off in the middle. And then you have the other one, which is kind of the case today, where you have a video, you're a bit smaller inside the video, and the video image. However, we don't support super small people in the background. We don't care actually about them. We don't want them. So we just omit them. So we only care about the big foreground guy or gal.
Thank you. Question for you, Nour. By the way, your cat is lovely. It's from Manuel. He asked, do you have a specific category for SizeNet, or is it a one model fits all?
Yeah, it's actually for like kind of broad category. So we use a model for women textile, for example, another for men textile. So it's really on broad level, but yeah, we see kind of differences between category performance, but it all depends on the amount of data. So for some categories that are really scarce, it's not performing as well as for others, for example.
Okay. There's a second part to that question as well. He asked, is the internal data set the basis for the famous fashion MNIST toy data set?
No, it's another data set. So the fashion MNIST is really low resolution and has this black background. It's like really the MNIST, the digit MNIST, but for fashion items. No, the data set that we use for SizeNet is because you need the full information of the garments also there. So the color, the pattern, everything can help for the size problem. So fashion MNIST won't work.
I would have guessed fashion MNIST, but I wasn't sure if it was just going to be wrong.
Yeah, just the name because of the MNIST.
I think Camille, I guess his question was aimed towards Elias because he just jumped in there just as you were finishing up your answer. So Elias, I guess this one's for you. Is like, does the model have a certain scale? So can I get the size of a person in meters?
No, I don't think so. It's all relative to the video size, right? No, but yeah, that's a different application.
I guess if you have your camera calibrated, maybe that could
yeah,
that could be possible.
Nice, excellent. Well, look, if anyone doesn't have any other questions, I'd like to thank everyone for their time. I'd like to thank our speakers, Rafael, Nour, and Elias. It was absolutely fantastic. Really impressed with everything. I'm going to post a recording of this as long as it's okay with everyone online via YouTube. Feel free to share it around. And if you're interested in some of the podcasts that I've recorded, Rafael, you can find his podcast on the Computer Vision and Production podcast channel as of today. And then Elias in the next couple of weeks. And then maybe, who knows, I might be annoying Nour with a follow-up email tomorrow about something similar. But thank you, everyone. Have a great evening, and I look forward to seeing you at the next events.
Thank you.
See you. Thanks a lot.
Bye.
Have a good day.
Wow.